afternoon, pilot teachers and students. Good afternoon, class.
Good afternoon, Mr.
Thank you very much. You sit down. All right, in our last lesson, I mentioned that in order for us to study radioactivity, we must know our chemistry. But this time, we will have to study and then look at different models of an atom. Now, I have asked two students to go through and then find out about the different models of an atom. And this time I will be asking them to come up and then explain those models of an atom. So pilot students and teachers, while these two students are going to explain the models of an atom, okay, I will be also with them, and then I will be asking you questions when they are going through the models of an atom. So I will now ask those two students to come up. Okay, one will be explaining while the other person will be going through each one of those slides. So may I ask Leon, Diane, and John. Okay.
This is the first model invented by Dalton. Can you please copy down the notes, pilot students, and
Okay, you can get. All right. Firstly, you can now go through the model students as well as the pilot students. You can go through now, and then copy the notes on each one of those models. And then after that, they will have to give you the diagram and then explain on that diagram. Okay, so this is the first model. Okay, have you finished copying the information? All right, you can now go through the model and then explain.
this is the diagram of how Dalton found out about the structure of the atom. He thought that it was like a ball bearing, a round sphere, as it looks here in the diagram. Can copy the diagram down.
Okay, just get that. You can now move on to the next model.
This is the next one. Leonard, can you please go through and copy it?
Finish. Okay. You can move on to the diagram now.
This is what looked like Leonard's model. You can see that there is a positive charge here and a negative charge. He thought that they were the dynamites. This shows that he thought that the protons and electrons were scattered around the atom. Can you please copy?
All right, if you want to quickly sketch the diagram and then they will move on. Okay, that is the next model.
The next model, Thompson's plum pudding. Can you please copy the notes?
Since everyone is finished, you can now move on to the diagram.
Thompson's theory about the atomic structure, he stated that there was a sphere and the electrons, they are scattered around the protons inside the circle, inside the sphere. So the electrons, the negatively charged electrons surrounded the sphere. They sorry, not the sphere, but the positively charged protons in the middle. Can you copy?
Okay. You can as well sketch the diagram too. The pilot students as well as the model students.
The next notes.
Okay, that is the next model. Okay, Rutherford's model of an atom. Quickly copy that and then they will explain to you the diagram.
This is the diagram of Rutherford's discovery. In his discovery, you can see that there is a small nucleus. He found that there is a small nucleus here in the center of the atom, which contains the nucleus and the protons in here. The neutrons and the protons. And it is said to contain the most of the mass of the atom. And the electrons here orbit the nucleus, like the sun, like the planets orbiting the sun.
Okay, quickly take down that sketch of diagram. All right, probably in your knowledge of the chemistry, why is it heavier? Why is most of the mass concentrated at the center? Amen. Okay, from your knowledge of chemistry, why is there a lot of mass in the center? Because, okay, one person, can you pass the mic down to Ume?
Because the nucleus contains the protons and neutrons, and they are more heavier than the electrons.
All right, very good. So because of the protons and the neutrons, which are more heavier because they weigh almost about 1.67, 2 times 10 to the power of minus 27 kilograms. While in the electron, you will find that it is about 9.3 times 10 to the minus 31 kilograms, which is more lighter than the proton and the neutrons. So that is why it is more massive in the center. All right, you finish the diagram, you can now move on to the last model.
This is a Bose model, the last theory of Bohr. Can please copy the notes. this is the diagram of Bohr's model. He stressed more on Rutherford's theory about the structure of the atom. He said that the electrons orbiting closest to the nucleus were the ground stage. He called it the ground stage. And as you move further out from the electron, from the nucleus, he said that the energy level increases. Just copy down the notes.
Okay, quickly go through and sketch the diagram. Right, in your chemistry, you should know there's different shells in an atom. Okay, shell 1 will be N1, N2 will be shell 2, and so on. Okay, you move out. So that is a diagram the students have presented. So quickly sketch that. Pilot students, you can have that diagram as well. All right, after the different models of an atom were put forward, Giga and Marsden developed an apparatus which will measure or find out exactly those models were correct. So looking at Leonard's model, the first one was when these alpha particles and also the electrons were fired into the models. Right, looking at that, I will explain first, and then the students will, these two will have to, right? There was something like this. Okay, you have okay, this one is a lead block. So in here you have something like a radioactive substance, and when this alpha particle was fired from this into gold foil, what happens was that some of these particles that came through into that were coming back, okay? They were deflected. So the students will be basing the explanation especially on how the real model of an atom was given. Okay, you can go through and then explain.
Leonard proved this atom theory like this. He showed the alpha rays that Mr. Simon showed through the atom, and it traveled straight through, and there was no deflection. So what he said was that the alpha rays don't touch anything in the atom. They don't come in contact with anything in the atom. They just travel right through. Can you please copy that diagram?
So we'll be also taking 10 minutes of your lesson because we'll take. Okay, thank you. Okay, for that model, you will find that an electron was fired into that, but then you find that it was undeflected, meaning that, okay, because Leonard's model believed that there was mostly empty space, and then you have dynamics which are a positive charge plus a negative charge. Okay, they were in pairs. So that is for Leonard's model. Okay, we can now move on to the next.
Thompson discovered that when an electron was shot into the atom, there was small deflection there. The electron just touched a few things there, and there was a small deflection in the atom.
Okay,
Please go.
for that, the alpha particle is simply a proton, meaning that it is a positive charge. And if Thomson's model says that the sphere is a positive, what do you expect to find? Samuel, what will happen if this alpha particle was fired?
It would be slightly deflected.
Okay, it will be deflected before it enters into that atom. So in this case, this model does not suit. All right, you can have diagram if you want to quickly sketch that, and then they will move on to the next. Okay, you can now go to the last.
And this is Rutherford's model showing the alpha particle path. Okay, as you can see, this alpha particle is positively charged. So when it was struck through the atom, it repelled because this is positive. The nucleus is positively charged, which repelled and then moved backwards. Yeah, it bounced backwards. Sorry. Can you please copy the diagram?
Okay, so based on that explanation, you will now see that Rutherford's model will now best fit the model of an atom, because when this positive charge was fired into, it easily went through, but then when it comes to the nucleus or the center, you'll find that there is a large deflection, meaning that half particle was deflected. So that shows that the positive part of an atom is especially in the center or the nucleus. All right, you can. All right. Thank you very much, those model students, for presenting your model of an atom. Okay. After you complete this, I will quickly go through and then summarize from what they have presented. Okay, looking at an atom, basically, there were a lot of people who came up with different ideas about an atom. Okay, you have ancient philosophers, Greek philosophers. Okay, one was Leucippus, and then you have Democritus, and then you have Aristotle. All right, those people base their philosophy of, let's say, their ideas of an atom based on philosophy or what they think. And Aristotle came up to influence the Greeks, saying that atoms were basically made up of 4 things: earth, fire, water, and air. Okay. And then you have Thompson, who came forward to put this idea or model of an atom. So after Dalton saying that the atom is basically a sphere, and it is something like only a ball. But then you have other people who came out of that. Okay, Leonard. Okay, Leonard came forward with this idea of an atom simply by having stated that the dynamites, or let's say a proton and an electron, are in pairs, and most of these are empty space. And then you also have Thompson, who came up to assume that an atom is like a model basically having a positive sphere, and then the rings are having some electrons. So when you goes on further, Rutherford came up to mention that especially the nucleus is massive, or right in the center of an atom, it has plenty of mass. And then he also stated that especially the electrons have high velocity, and then they have to move around the nucleus, having some kind of mass and speed as well. But and then after Rutherford, Bohr came up with mentioning his model of an atom as saying that as you move from the center outwards, the energy level increases. Okay, so from there, Giga and Marsden developed a machine, or let's say an apparatus, which will find out which model was the best to fit into an atom. So they tried firing an electron into Leonard's model, but this time it went undeflected because it was not true of an atom. And then secondly, they did the same thing with Thompson's model. But Thompson's model, you find that especially when it goes through, before it goes right into the atom, it will be deflected because the positive is, or the sphere is simply positive. But this time it was not deflected, it went right through. And so finally, using Rutherford's model of an atom, they tried firing this alpha particle, which is a positive or proton, into. And then what they found out was that, especially in the center, this alpha particle was deflected. So they came up with an atom as having electrons on the outer part, and then you have the center, which is having protons and neutrons. So that is how the atom was first discovered, by experimenting and all this. So in our next lesson, we'll basically going through and then looking at the ions, and also we'll be studying one of the early instruments that we use to measure or find out the about the atoms. So our keyword for today, or key phrase, will be basically the models of atoms. So good afternoon, pilot teachers and students. Good afternoon, class. Good afternoon. Okay, you can sit down.